Good day, my dear students. I made this video clip in order to all of you be guided in your self-study. I hope you will watch this from start to finish. This will guide you in your General Mathematics Modules 24, 25, and 26. Again, please keep on watching as I start the lesson. First, we will talk about the introduction to logarithms, focusing on converting exponential form to logarithmic form and vice ganda. Sorry, vice versa. Let us first define what is a logarithmic function. For all positive real numbers x and a such that a is not equal to 1, there exists a real number y such that y is equal to log of x with base a if and only if x is equal to a to the y. Also, it can be written by f of x equals log of x with base a. The logarithmic function is the inverse function of the exponential function with base b. For x is greater than 0 and b is greater than 0, where b is not equal to x, y equals log of x with base b is equivalent to b to the y equals x. The function f of x equals log of x with base b is the logarithmic function with base b. For this time, let us talk about the location of base, exponent, and power in exponential and logarithmic form. The logarithmic form, again, is equal to y is equal to log of x with base b. The exponential form is b to the y equals x. The exponent in exponential form is the value of the logarithmic form. The base of exponential form is also the base of logarithmic form. It is written as subscript of the expression log. The value or the power in exponential form is the basis of computation in logarithmic form. By means of that, we can say now that logarithmic form can be converted into exponential form and vice versa. To prove that the conversions I am saying to you is true, we will convert exponential form to logarithmic form. Again, the exponential form is b to the y equals x. We will be converted into its logarithmic form, y equals log of x with base b. Example, the exponential form 5 squared equals 25 in logarithmic form is, the base 5 will be written as subscript of the expression log, and the power 25 or the value 25 will be the basis of computation of logarithm, and the exponent 2 will be the value of the logarithm. Therefore, 5 squared equals 25 in logarithmic form equals the logarithm of 25 with base 5 equals 2. Example number 2, 64 to the 1/3 equals 4 in logarithmic form is log of 4 with base 64 equals 1/3. Third example, 2 to the negative 5 equals 1/32 in logarithmic form is equal to log of 1/32 with base 2 equals negative 5. To continue, we will convert logarithmic form into exponential form. In this part, we will convert logarithmic form log of x with base b equals y into exponential form b to the y equals x. Example number 1, convert into exponential form log of 1 with base 9 equals 0. To convert its exponential form, the base 9 or the subscript in logarithm will become the base in exponential form, and the value of the logarithm 0 will become the exponent in exponential form, and the basis of computation 1 will become the value or the power in exponential form. Another example is log of 1000 equals 3. Its exponential form is, the base is imaginary 10, its value of the logarithm will become the exponent, and it is 3. and the basis of computation 1000 will become the power of the exponential form. Therefore, log of 1000 equals 3 in exponential form is 10 cubed equals 1000. Third example, log of negative 343 with base 3 equals 5. Again, the base of logarithm negative 3 is also the base in exponential form. The value of the logarithm 5 will become the exponent of negative 3, and the basis of computation of logarithm negative 343 is the power of the exponential form. Therefore, log of negative 343 with base negative 3 equals 5 in exponential form is negative 3 to the 5th equals negative 343. And now, to sum up our module 24, the value of the logarithm is the exponent in exponential form. Therefore, logarithm is another form of exponents. Why we have logarithm? There are exponential forms that is hard to solve, particularly if we don't have scientific calculator, and it can be solved using logarithmic function. That's the reason we have logarithmic function. Now, let's proceed to your module 25. The topic is distinguishing logarithmic function, logarithmic equation, and logarithmic inequality. Let us first define them one at a time. Logarithmic functions are the inverses of exponential function. The inverse of the exponential function y equals a to the x is x equals a to the y. The logarithmic function y is equal to log of x with base a is defined to be equivalent to the exponential function x equals a to the y. Examples of logarithmic functions are f of x equals log of 5x with base 6. Another, d of x equals log of 64 with base 2. Next, y equals log of 78. Last but not the least, t of x equals log of 156 with base 5. Next is logarithmic equation is an equation that involves the logarithm of an expression containing a variable and with equal sign. Examples of logarithmic equations are log of 15 with base 5 equals x. Another, log of 3/4 with base x equals 256. Next, log of 64 cubed with base 4 equals x. And last but not the least, log of 5 quantity x plus 2 equals log of quantity x minus 4. To continue, logarithmic inequalities are inequalities in which one or both sides involves logarithm. Like exponential inequalities, they are also useful in compound interest and exponential decay. They have the symbols less than, greater than, less than or equal to, or greater than or equal to. Examples, log of 34 with base 5 is less than 56. Log of x with base 7 is greater than log of quantity x minus 9 with base 7. Next, log of 343 squared with base 3 is greater than or equal to 12x. And last but not the least, log of x with base 2 is less than or equal to log of 64 with base 8. Guys, my dear students, if the video is too fast for you, you can stop, you can pause or rewind the video for better understanding. At this moment, please go along with me answering the activity 1. The direction, determine the following as logarithmic function, logarithmic equation, or logarithmic inequality. Dapat, pagbilang ko ng 3, may sagot na kayo. Are you ready? Let's begin! Number 1, 3 log of 1024 with base 2 equals x is a logarithmic equation because it has equal sign and only one variable. Number 2, f of x equals log of 81x plus 4 with base 4 is a logarithmic function because it has f of x. Number 3, log of 36x is greater than 0 is a logarithmic inequality because it uses the symbol greater than. Number 4, 4 log of quantity x minus 3 with base 3 is less than or equal to log of quantity x plus 1 with base 12 is a logarithmic inequality because it uses the symbol less than or equal to. Number 5, h of x equals log of quantity x plus 5 squared with base x is a logarithmic function because it has the expression h of x. Number 6, 5 equals the logarithm of 67 with base x is a logarithmic equation because it has one variable and uses the equal sign. Number 7, the logarithm of m equals the logarithm of quantity 2m minus 3 is a logarithmic equation because once again it has one variable and uses the equal sign. Number 8, negative 6 times the logarithm of 3 quantity x plus 13 equals negative 134. A logarithmic equation because it has one variable and uses the equal sign. Number 9, the logarithm of 19 is less than the logarithm of x. A logarithmic inequality because it uses the symbol less than. 10th and last example for this video, g of x equals log of quantity x squared minus 2 with base 4 is a logarithmic function because it has the expression g of x. Again guys, thank you for cooperating to our activity number 1 and continue watching the videos. Again, that is your guide in order for you to answer or to learn easily Module 25 of your General Mathematics. Now, let's proceed to your module number 26, solving logarithmic equation or solving logarithmic equations. Module 26 divided into 3 subtopics. So I have 26A, 26B, and 26C. In 26A, I just focus on laws of logarithm. Again, please be with me of reciting this definition of terms. Number 1, common logarithms are logarithms with base 10. Log x is a short notation of log of x with base 10. Again, in common logarithm, the base 10 is imaginary or not written. So it is simply log of x. Number 2, natural logarithms are logarithms to the base e and are denoted by ln. ln stands for natural logarithm. So ln x is another way of writing log of x with base e. The third definition is laws of logarithm are rules that allows logarithmic expressions be written in different ways. And that is the focus of Module 26A. Let us now discuss the laws of logarithm. Law number 1. The logarithm of mn with base b equals the logarithm of m with base b plus the logarithm of n with base b, or it is called the product rule of logarithm. And just because, as I said, logarithm is another form of exponent, the law came from the property of exponent x to the m times x to the n equals x to the m plus n. If you will notice, to multiply exponent, we are just adding them. That's why the first law or the product rule, we add the logarithm of m and n. Examples of product rule are log of 6x with base 4 equals log of 6 with base 4 plus log of x with base 4. If you will notice in this example, 6x is a product. That's why we added log of 6 with base 4 plus log of x with base 4. We just separate 6 and x. Example number 2 is log of 8x squared y with base 2 equals log of 8 with base 2 plus log of x squared with base 2 plus log of y with base 2. Again, we just added the three factors, 8, x squared, and y. Last but not the least example is log of 4 times 5 with base 7. Just because 4 and 5 are product, we will add log of 4 with base 7 plus log of 5 with base 7. Law of exponent. Law logarithm number 2 is log of quantity m over n with base b equals log of m with base p minus log of n with base b is called quotient rule. Quotient rule came from the property of exponent called quotient of powers. X to the m over x to the n equals x to the m minus n. That's why this law number 2, we just subtracted the logarithm of m minus the logarithm of n. Examples for this law of logarithm number 2 are number 1, log of quantity m over 3 with base b equals log of m with base b minus log of 3 with base b. Number 2, log of 64 over 9 with base 4 equals log of 64 with base 4 minus log of 9 with base 4. Third example, log of quantity 8x over y equals log of 8 plus log x minus log y. In this particular example, we combine two laws. 8x is product rule, over y is division or quotient rule. That's why we added 8 and x subtract by log of y. Law of logarithm number 3. Log of m raised to k with base b equals k log of m with base b is called power rule. In power rule, it is very easy. We will make the exponent k as coefficient of the given logarithm. Examples, log of x cubed with base 6 is equal to 3 log of x with base 6. Again, as you observe, the exponent 3 became only the coefficient of log of x with base 6. Example number 2, log of 9x to the 5th equals log of 9 plus 5 log of x with base 6. In this, we can observe again two laws of logarithm. 9 times x to the 5th is product rule. That's why we added. And the power rule, the exponent 5 became the coefficient of log of x. Example number 3, log of quantity 8x over y raised to the 5th equals 5 log of 8 plus log x minus log y. If you will observe, 5 is outside the parentheses. That's why 5 is the coefficients of the three factors inside the parentheses. Law of logarithm number 4 states that log of 1 with base b equals 0 is called the zero rule. It came from the Law or property of exponent, x to the 0 equals 1. Meaning, in all the logarithms of 1, in any base, the value is always a 0. Examples, log of 1 with base 12 equals 0. Log of 1 with base 4 equals 0. Log of 1 with base p equals 0. If you will observe, they have different bases, but the value of the logarithm is always a 0. And that is law of logarithm number 4. Fifth and last law that I will discuss in this video is law number 5. And again, this is not the list just because there are other laws expanding the law, any of the laws in this law 1 to 5. Law number 5 is stated that log of b with base b equals 1 is called identity rule. Identity just because the basis of computation and its base are the same or identity. So it is very easy. If that's the case, the value is always 1. Example, log of 8 with base 8 equals 1. 8 is the value to solve for logarithm and its base is also 8. That's why it is 1. Another log of 10 equals 1. Log of 10 is a common logarithm. We know that common logarithm has an imaginary 10 as base. So therefore, it is 1. Log of 65 with base 65 equals 1. Again, if the value and the base are the same, the logarithm is always 1. That laws of logarithm I discussed to you, my dear students, are applicable in solving logarithms like what you are seeing on the screen. But for this video, we will not solve that. I have another video special only for that topic, just because it's quite long. For our activity number 2, we will be having a puzzle, building, and the contents of that puzzles are bases on our modules discussed for this video. The directions are, for numbers 1 to 4, we will match the correct conversions from logarithmic form to exponential form or vice versa. For items number 6 to number 10, we will match the appropriate applications of laws of logarithm like what I just discussed recently on this video. To further instruct you how you will make the puzzle, continue watching the video as I illustrate to you how you will perform or how you will build up the puzzle. Dito nga guys ay didemo ko sa inyo kung paano natin sasagutan yung puzzle sa ating activity. Ayan, meron tayo dyan 10 items at ito yung pagpipilian natin ng mga possible na sagot. Ang unang gamit nito is mag-enjoy tayo, build natin ang puzzle. Kung alam na natin, kung naintindihan na natin yung video, i-fill up na natin siya. Okay, ito 28. Tulad nito 28. Ano ba ang kanyang base? 28. Ano ang exponent? O 0. So mali yan. Ito ang gagawin natin. Okay. Pakilagay lang. Then, kung sigurado na kayo, pwede naman nating lagyan ng tape para hindi sila maghiwalay. Kasi DIY nga lang yung ating puzzle. I made it in the simple way. Okay, next is 512. Much better. Ikalat natin. Para i-select na lang natin kung ano yung mga tamang sagot natin. Okay. Pwede namang ikalat. Meron diyang tama at merong mali. Yan. Kalat natin yung mga pagpipilian. Okay. Number 1 is log of 512 equals 3. So, ano ang base natin? Ang base ay 8. So, ito ang pwede nating pagpilian. Isa. Saan pa yung isa? Ito. O, alin kaya sa dalawa ang pwede nating i-match dito? The base is 8. Ayan. Lagyan ng tape. Kaya dapat may scotch tape kayo sa mga bahay ninyo. Ayan, pag sigurado na, lagyan ng tape. Proceed tayo. Hanapin natin ang may 343 dyan. Isa at, ayan, dalawa. So, which of the two is you think correct? The base is 7. Base is 3. Okay, so we will here. Okay, that's it. Then, if you are now sure, you can make it temporary permanent by using a scotch tape. Again guys, DIY lang to. Pinakamatipid kong ginawa. Ayan, kung sigurado na. Ito at hindi siya kasali, pwede nang ialis para hindi na makalito. Next is 1296. Ilan? Since no other choice, so yan na yun. Sigurado ka na, may tama ka ng isang sagot. Ganito lang, continue lang hanggang matapos natin yung puzzle. Hanggang masagutan natin lahat.
Next, 5x. Ano dyan ang may 5x? 5 at saka x. Ayan. Oh. Pili tayo. Alin kaya sa 4 ang tamang sagot. Okay. Since that is add, ito. Ayan. Then, again, kung sigurado na, i-fix natin ang scotch tape. Repeat the process hanggang matapos natin yan. Next, 5 over x, yung minus, hanapin natin. Kung sumapinit natin. Ayan.
At kapag yan ay na-perfect ninyo, ibig sabihin, naintindihan nyo yung nilalaman ng video.
Next, 12x to the 4th. 5. So yan. Wala yata ang sagot. Ayan.
Ito ang unang gamit ng puzzle para i-deepen pa or palaguin pa yung ating mastery, yung ating napanood sa video.
Next. Yan, piliin mo lang yung alam mong tamang sagot base sa iyong pagkakaintindi sa video. Okay, madali na tayo.
Sa puzzle na ito guys, hindi lang tayo natuto ng logarithm, natuto pa tayong gumamit ng scotch tape. At ng kanyang dispenser. At para ma-reveal kung tama nga ba yung ating sagot, pwede nating baliktarin o may guhit dyan, tanggalin natin. Yan. Kung ang thumbs up ay buo, as you see, ibig sabihin, tama ang ating, ayan, tama ang ating sagot.
Hindi ko alam ah.
At kung ganito ang nangyari sa figure, ayan. So, ibig sabihin, mali-mali ang iyong, may mga mali sa iyong sagot. Ulitin mo. Another way of using the puzzle is use it as answer key. Kung confident naman kayo na naintindihan niyo yung video, so kopyahin natin yung activity. Kopyahin natin at sagutan natin ayon sa ating pagkakaintindi. Tapos natin kopyahin, sagutan natin ito. Matapos sagutan, set aside na muna natin. Babalikan natin yan mamaya. At gagamitin natin itong puzzle, yung likod. Then, kalat natin yung mga tiles natin. Bubuuin natin ngayon yung ating puzzle. Tulad ng dati, pag sigurado na kayo, lagyan natin ng tape para magsama-sama sila. Kasi again, DIY yung puzzle natin na kailangan ng tulong ng tape. Sa activity ito guys, na-i-improve ang ating imagination, ang ating decision making. Na-i-improve din ang paggamit natin ng tape at ng tape dispenser. In other words, hindi lang mathematics ang natutunan natin sa pagbuo ng puzzle. Ayan guys, malapit na nating mabuo yung puzzle. Malapit na nating ma-reveal yung mga sagot at ma-check kung tama ba yung ating mga sagot at kung sakaling tama lahat yung sagot natin, 100% or mostly naintindihan natin ang contents ng video. Ang puzzle naman guys, habang umuunti yung tiles natin, papadali. Ganon din ang mathematics, habang tumatagal at dumadami ang ating natutunan, ang mathematics ay nagiging madali sa atin. So, tiyaga at tiyaga lang guys. Tiyaga lang tayo para maging mas magaling pa tayo sa mathematics. Ayan, last na to. Ayan, last na. Okay.
Oh, no.
Hindi guys. Pagpalit natin.
Ginagawa mo.
Yun, tama. Kaya pala maluwag. Okay, nabuo na natin ang ating puzzle. Mag-check na natin kung tama yung ating sagot. Okay. Since na tama na siya, baliktarin na natin yung ating puzzle at kunin na natin yung ating sagot. Okay, let us check now. O yan, tama lahat.
Ma'am, galing mo pala dyan ah. Hindi ko alam ah.
So, ganyan po ang second use ng ating puzzle. We can use it as answer key and we will use this as discovery of the answer. After the puzzle, kindly answer the process questions and kindly include that in your outputs that you will pass during the retrieval. Number 1, what did you feel when you first see the puzzle? Number 2, how did you answer the puzzle? And number 3, how the puzzle helps you learning the lesson. Once again guys, my dear students, I hope this video clip helps you simplify your modules 24, 25, and 26. For further learning of module 26, 2 videos are already downloaded in our respective group chats. Please click and watch. And also, you can reach me on my YouTube channel, Math Help at Iba Pa. Please subscribe for more videos of your further lessons. Once again, I am Sir Nilo, your math virtual teacher in this modular distance learning. Good day, everyone.